Okay, so today we're going to go on to section 5.5, multiple angle identities. So here we have what's called the double angle identities. So I need Ivy, go ahead and read. Okay, thank you. So these are the double angle formulas. Notice that cosine has three different ones. So what we're going to do is we're going to find these double angle identities. So let's start with example number 1. So if cosine theta equals 3 over 5 on this interval from 0 to pi over 2, we're going to find sine 2 theta, cosine 2 theta, tangent 2 theta. So let's begin. We're going to begin by drawing a right triangle. So we're going to draw a right triangle. And we're going to label it. I'm going to label it theta here. Now, they're giving me that cosine is 3 over 5. And remember that cosine is adjacent over hypotenuse. So the 3 has to be the adjacent side, this one. And the hypotenuse is 5. So we need to find the other side by using the Pythagorean theorem. So we're going to say a squared plus 3 squared equals 5 squared. That'll be a squared equals 25 minus 9, which a squared equals 16. So a equals plus or minus 4. Since this is a right triangle and we're looking at length, the side is only going to be 4, not negative. So now that we know that, let's find sine of 2 theta. We're going to write it up. Sine of 2 theta. And according to our identities, sine 2 theta is the same thing as 2 sine cosine theta. So I'm going to write that out. So 2 sine theta cosine theta. So now I will look at the triangle and I want to find sine of theta. Sine of theta is opposite over hypotenuse. So opposite 4 over hypotenuse 5. 4 over 5. And cosine was already given to us. It's 3 over 5. And one more thing I forgot to say. We are in quadrant 1. So therefore, it's going to be positive. So now, all we have to do is multiply. So 2, you can write it as 2 over 1 if you want. But it's going to be 2 times 4 times 3. 2 times 4 is 8, times 3 is 24. 5 times 5 is 25. That is sine of 2 theta. Okay, so now we're going to find cosine of 2 theta. Cosine of 2 theta. Now for cosine of 2 theta, we have 3 options. You decide which one. I'm going to go with the first one. Cosine squared theta minus sine squared theta. Kareem, put your phone away, please. Pay attention. Okay, so we know what cosine is. Cosine is 3 over 5. We're going to square it. Minus. And sine, we know what it is. It's 4 over 5. We're going to square it. Let's square it. We get 9 over 25 minus 16 over 25. And if I simplify that, we get 9 minus 16, negative 7 over 25. That's your answer. Finally, we're going to find tangent to theta. So tangent to theta equals, let's look at the identity. It's 2 tangent theta. So 2 tangent theta over 1 minus tangent squared theta. So here we go. If I look at the triangle, tangent is opposite over adjacent. So again, opposite over adjacent, 4 over 3. So tangent theta is 4 over 3. So now it'll be 2 times 4 over 3 divided by 1 minus 4 over 3 squared. Let's do the math. In the numerator, we're going to get 8 over 3 divided by 1 minus 16 over 9. Let's simplify. So 8 over 3 divided by this one, I'm going to rewrite it as 9 over 9 minus 16 over 9. That's going to be 8 over 3 divided by negative 7 over 9. Now here you can do this little trick where you multiply these outside ones and then these, and you can simplify after that, or you can simplify first. I noticed that the denominators can be reduced by 3, so I'm going to reduce it by 3 first. So if I reduce them by 3, it'll be 8 over 1 divided by negative 7 over 3. Now I can do this little trick where we multiply. So that'll be 8 times 3 is going to be 24 over 7. And since there's a negative involved, I'm just going to put the negative in front of negative 24. And that is your tangent of 2 theta. Okay, example number 2. We're going to do the same thing, but this time they're telling me tangent theta is 8 over 15. And the interval is 180 degrees to 270 degrees. Now remember that tangent is opposite over adjacent. So let me label the right triangle, which I already drew. So opposite will be 8, and adjacent will be 15. By using the Pythagorean theorem, the hypotenuse becomes 17. Now, one more thing. This is in quadrant 3. So remember, all students take calculus. So let's find sine 2 theta first. Sine of 2 theta is 2 sine theta cosine theta. So now we look at our triangle, we figure out what is sine of theta. So let me write out 2 times sine of theta. Here's theta. Sine is opposite over hypotenuse. So that's going to be 8 over 17. But we are in quadrant 3, so that makes it negative. Now cosine is adjacent over hypotenuse. Adjacent is 15. The hypotenuse is 17. And we are in quadrant 3, so that's going to be negative again. So negative 15 over 17. So now it's just using a calculator. So let's multiply. We're going to multiply 2 times negative 8 times negative 15. That's going to give me 240 over 17 times 17. It's going to be 289. And then you can check to see if you can simplify that by using a calculator. And let's see. No, let's leave it like that. So that is your answer for sine 2 theta. Okay, now let's find cosine of 2 theta. So cosine of 2 theta. Like I said before, you have 3 options to choose from. I'm just gonna go with the first one. Doesn't really matter which one you use, you'll get the same answer. So I'm gonna use the first one, this one. So it is cosine squared theta minus sine squared theta. So now let's plug it in. Cosine theta was, it's right here, negative 15 over 17 squared minus sine is negative 8 over 17 squared. So what we're going to do is we're going to square that. So let's see. Once we square it, it's going to be positive. But let's see. 15 squared is 225. And 17 squared is 289 minus, so I already know the denominator for this one, 289. It's the same thing. And this one is 64. So then here all we have to do is just subtract. So 225 minus 64, that's 161 over 289. Final answer. Now we need to find tangent to theta. Let's see. Let me set it up here. So tangent of 2 theta is defined as 2 tangent theta divided by 1 minus tangent squared theta. Let's double check just to make sure. Yes. So now, let's see, let me separate this. Now we need to find tangent. Now tangent is defined as, here's the angle, the opposite, which is 8, over the adjacent, which is 15. So it'll be 8 over 15. So 2 times 8 over 15 divided by 1 minus 8 over 15 squared. The numerator is easy. That's going to give me 2 times 8 is 16 over 15 divided by 1 minus, if I square 8 over 15, I get 64 over 225. So if I want to simplify more, the numerator stays the same. Denominator, I'm going to rewrite it as 225 over 225 minus 64 over 225. Again, numerator stays the same. Let's simplify the denominator. So 225 minus 64 is 161. Well, I had it already. From here, so 225 so now I'm going to simplify, but before I do that, the denominators, these both numbers can be divided by 15. So if I divide it by 15 before I multiply, it's going to give me, let's see, 16 over 1 divided by 161 over 15. Now I'm going to multiply like this. Those two, and then these two. So final answer should be, let's see, 16 times 15. That's 240 over 161. Final answer. Okay, so now we're going to solve an equation that has a double angle. So what we need to do is that we need to rewrite this cosine to theta with a double angle identity, but we want to make sure that it has only sine in it. So notice this one has cosine and sine, this one has cosine, this one has only sine. So I'm going to use a third one. So let's rewrite it. So this cosine to theta becomes 1 minus 2 sine squared theta equals negative sine theta. Now, this looks like a quadratic. Think of 1 minus 2x squared equals 2 negative x. If it looked like that, then we would set it to 0 and then solve by factoring or something like that. So let me erase this. And what I'm going to do is I want to make sure this one is positive. So I'm going to send it to this side along with the 1. So if I do that, on the left side, we're going to end up with 0. And on the right side, we're going to have a positive 2 sine squared theta minus sine theta minus 1. Now, think of when we would solve a quadratic where we do the x factor. And on top, we'll have a negative 2. And on the bottom, we're going to have a negative 1. So I need two numbers that multiply to give you a negative 2, but add up to a negative 1. That would be a negative 2 and a positive 1. But remember, this one starts with a 2. So I have to do that extra step that I've taught you. So it'll look like this. 2 sine theta minus 2. So that means I have to divide by 2. So 0 equals, that's going to give me sine theta minus 1 times the other one. We're going to get 2 sine theta plus 1. There we go. We factored it. So now we're going to say, when is this equal to 0? So take the opposite of a negative 1 and set it equal to sine theta. Sine theta equals 1. We're going to do the same thing. Take the opposite of positive 1 and divide by 2. So it'll be sine theta equals negative 1 over 2. So for this, you need to know your unit circle. And notice that the interval is from 0 to 2 pi only. So where is sine theta equal to 1? Sine theta equal to 1. That's when theta is equal to pi over 2, because sine of pi over 2 is 1. And for this one, where is sine theta equal to negative 1/2? When theta is, now in this situation, negative 1/2, that means sine is negative. That means we are either in quadrant 3 and 4. So that means that the angles are going to be related to pi over 6. That will be 7 pi over 6 and 11 pi over 6. Okay, let's try another one. Now, notice that this one, cosine of 2 theta, that's the one we want to rewrite. This one has a cosine. So when I look at my identities, I wanna replace it with the one that has only cosines. So this one, 2 cosine squared theta minus 1. So let's get started. Let's rewrite it. So this becomes 2 cosine squared theta minus 1 plus 4 cosine theta equals negative 3. So again, it looks like a quadratic to me. So that means I want to set it equal to 0 and put it in descending order. What I mean by that is I want my cosine squared to be first. So 2 cosine squared theta, and then plus 4 cosine theta. And when I add the 3 to the other side, to this one, that's going to give me a positive 2 equals 0. So now, again, before we do the x factor, I notice that I have a 2 in front, I have a 4 in front, and a 2. That means that I can divide everything by 2 since it's equal to 0. Okay? It has to equal to 0. If not, you can't do that. So if I divide everything by 2, I have cosine squared theta plus 2 cosine theta plus 1 equals 0. That makes things easier. So now I can do the x factor. And on top, we need a 1. And on the bottom, 2. So this is a tough one, guys. Two numbers that multiply to 1, but add up to 2? I think that would be 1 and 1. Right, Isa? Yes. Okay, good. Glad you're paying attention. All right, so now we can factor it. It's going to be cosine theta plus 1 times cosine theta plus 1 equals to 0. Now, you don't have to do this twice. It's exactly the same thing, so only once. So, like I said it before, the opposite of positive 1, and set it equal to cosine. So, cosine theta equals negative 1. So, on the unit circle, where is cosine equal to negative 1? The only place is when theta is equal to pi. There you have it. Okay, so now we're going to go on to what's called a half angle identity. So what I want you to notice is that this time we have the angle theta divided by 2. So we have these formulas. For sine theta over 2, we have this one, plus or minus. For cosine theta over 2, we have this one, plus or minus. And for tangent, you have 1, 2, 3 options. For tangent, the easiest is always going to be this one. So we always want to try to use that one, the middle one. It's always easier. So here we go. Find the exact value of each expression. Sine of 75 degrees. Okay, so what we want to do is set 75 degrees, or better yet, do it this way. Theta over 2 equals 75 degrees. So what I want to do is solve for theta. Solving for theta, we have to multiply both sides by 2, so theta equals 150 degrees. That's the angle we're going to use. Also notice that this is quadrant 1, and therefore we want it to be positive. So if I go and look at sine, we have this option. So it'll be, let's go back to it again. It's going to be, so sine of 75 degrees equals, actually, let's write it as sine 150 over 2, because that gives me my 75, and that means that 150 is my angle. And if I look at the formula again, it's the square root 1 minus cosine of theta. Theta is 150 degrees over 2. Now, notice that the formula has positive, negative, but since 75 degrees is in quadrant 1, we're going to keep the positive root. So let's just evaluate. So now it's the square root of 1 minus the cosine of 150. The cosine of 150 is going to be negative square root of 3 over 2, because we are in quadrant 2, divided by 2. That's going to be square root 1 plus square root of 3 over 2, plus, because we have a negative and a negative, all of that divided by 2. Now, let's simplify this first by rewriting the 1 as 2 over 2 equals square root. So if it's 2 over 2, that means I can add them. So it'll be 2 plus square root of 3 over 2, all of that divided by 2. And if I imagine this one is over 1, again over 1, that means all I have to do is multiply this one and this one together, and we're done. So final answer is going to be square root of 2 plus square root of 3 over 4. And we can just leave it like that for now. Okay, let's do one more with half angle identities. This one is tangent. So to find theta, what I want you guys to do is do the same thing again. Say theta over 2 equals 7 pi over 12. if I cross multiply, we get theta equals to 14 pi over 12. And if I reduce that, we get theta equals 7 pi over 6. So that's going to be our angle that we're going to use. Now, that means that I can rewrite it as tangent of 7 pi over 6 divided by 2. That gives us our 7 pi over 12. Keep in mind, this is our theta. So now, if I look at the half angle identities, we have 3 options. But the one I want to use is this one because it makes things easier. So 1 minus cosine theta divided by sine theta. So 1 minus cosine of 7 pi over 6 over sine of 7 pi over 6. Now, 7 pi over 6 is in quadrant 3. So what I need you to look at is pi over 6. 1 minus. Now, the cosine of pi over 6 is square root of 3 over 2. But we are in quadrant 3, so that makes it negative. Negative square root of 3 over 2 divided by 1 minus the sine of 7 pi over 6. It's going to be negative because we are in quadrant 3. So think of pi over 6. So the sine of pi over 6, if you're using the left hand method, remember the left hand? Okay. It is negative 1/2. Let's start simplifying. Mariana, are you on your phone? Get off your phone. Come on. Okay. So it'll be 1 plus square root of 3. Square root of 3 over 2 divided by 1 plus 1 over 2. Let's simplify. So this one, if I rewrite the 1 as 2 over 2, same thing with this one, it's going to give me 2 plus square root of 3 over 2 divided by 3 over 2. And if I do that trick that I taught you, but before that, notice that the denominators are exactly the same. So that means they're going to cancel out. And if they cancel out, if this is gone and this is gone, then we're left with 2 plus square root of 3 over 3. Final answer. Okay, last example. This one, we're going to solve an equation which requires us to use the half angle identities. So I want you to notice that this one has a half angle. So we want to rewrite it as one of these, actually for sine only. So let's start by doing that. Let's rewrite it. And notice also that it is squared. So it'll look like this. 2, and then the half angle identity tells me that I'm going to rewrite it as plus or minus square root 1 minus cosine theta over 2. All of that squared plus cosine x equals 1 plus sine x. Now, I'm going to go back to this. I just noticed something. Theta and x doesn't matter what you use, so we want to have the same variable. So what I'll do is change the theta to x, make things easy, and you guys won't be confused. So now, what I'll do first is square. So if I square this, that means this is gone. It's going to become a positive. The square root is gone also. So now we have 2 times 1 minus cosine x over 2 plus cosine x equals 1 plus sine x. So now what happens is that these two cancel out. I can literally just cancel them out. So now we have 1 minus cosine x plus cosine x equals 1 plus sine x. So I notice that negative cosine and a positive cosine, they go to 0, they're gone. And if I subtract the 1, because I want to leave the sine x by itself, that means this one and this one, they're going to cancel each other out. And it's going to give me 0 equals to sine of x. And now notice this horrible looking equation is simply this. When is sine of x equal to 0 on this interval? And that's going to be at two places. X equal 0 because sine of 0 is 0. Pi because sine of pi is 0. And since 2 pi is included, we're going to say 2 pi also. And that is your answer.